So, first question here on the notes, what's the inverse of y equals natural log of x? So what do we do to find an inverse? Switch x and y, so let's start off with that. We're going to have x equals natural log of y, and then we would solve for the new y. So we can think of this as like log base e of y equals x. What's that equal to if we change it to exponential form? E to the x equals y, right? So that right there, y equals e to the x, that's the inverse of natural log. Oh, we're going to be looking at the exponential function today, e to the x, and its derivative. First, we're going to find its derivative using logarithmic differentiation like we did on Friday. So, what is this derivative? Let's start off. Y equals e to the x. So, when we learned about logarithmic differentiation, we were doing this in those scenarios where we had an x in the exponent. So, this is one of those scenarios. After we do this the first time, this is going to be one of the easiest derivatives you'll ever remember. So, let's take a look. We're going to do natural log of both sides. Then, we would want to simplify this right side. What we would do most of the time is take this exponent and bring it out in front. But there's an easier way to even simplify this. What's natural log of e to the x? Just x. Right? This is log base e of e to the x. So log base e of something and e to a power, those are inverses. They're opposites. They cancel each other out. So we just get x. So it makes it real simple on that side. Over here we have natural log of y. So now that we've simplified things using properties of logs, we're going to take the derivative of both sides. So derivative of natural log of y, in terms of x, we have 1 over y times dy dx. What's the derivative of x? 1. So to get dy dx by itself, we were multiplying both sides by y, so dy dx is equal to y, which is equal to e to the x. Has your mind been blown? The derivative of e to the x is e to the x.
What?
Exactly. What? That means that if we have the function y equals e to the x, we look at that graph, if we look at this graph right here, every y value on this graph is not only the y value of the graph, but it's also the slope of the graph at that point. So like one point that we know here is 0, 1. The y value is 1. The slope of the tangent line is also 1. So if wherever the y value is 2, the slope right there is 2. Wherever the y value is 3, the slope at that point is 3. So this is a pretty unique function where its derivative is actually the function itself. Now, we're not always just going to have e to the x. We're generally going to have e to some power in terms of x, so e to the u. When we have to take the derivative of that, we're just using chain rule, and we get e to the u. It stays the same, basically, but then we have to multiply by the derivative of u with respect to x. So we're just multiplying by the derivative of that exponent.